Pseudocode! For years, it's been a way to sketch out designs for a number of developers, but these days, the AI world has reclaimed the practice to enhance a number of LLMs. Today, we're going to explore the world of pseudocode, how it works, and how to make characters or prompts with it. Let's get one thing straight though, there is no one-size-fits-all, gold-plated, or universally recognized best practice when it comes to this stuff. The world of pseudocode is a bit like the Wild West, full of possibilities, but with no sheriff in town to really lay down the law. Pseudocode is a more advanced method of prompt engineering that is considered a best practice, quote-unquote, for creating character cards, designing jailbreaks, and setting up predictive analysis bots. It's always a good idea to use some form of pseudocode when you're setting up a chatbot, so try not to get hung up on the specifics. You'll be just fine playing it fast and loose here. In the context of AI, pseudocode sits comfortably between being human-friendly and token-friendly. What is pseudocode anyways? Let's start with the basics. Pseudocode is like a UN translator. It's there to bridge the language gap. Pseudocode is considered an agnostic programming language, meaning it doesn't have a hardline bias towards any one coding language. It's in that sweet spot where something is structured enough to be digested by an AI model, but still readable by a mere meat popsicle like myself. So why is pseudocode so useful, you ask? Well, beyond being a token-friendly way of prompting and jailbreaking, it's all about the way it segments data. When you feed information into an AI, imagine it as trying to send a delicate souffle through a fucking tornado. A lot of complex math gets involved, hyperbolic tangents, linear and nonlinear equations, and all the good stuff that makes my brain hurt. Pseudocode acts as a safety net, ensuring that your souffle, or in this case, our nuanced data, doesn't come out the other end as scrambled eggs. It keeps things in order so that the information doesn't get jumbled up when it's being squashed and stretched. Of course, pseudocode isn't infallible. Nothing really is, but it's a fantastic way to keep your AI from turning into a nonsensical word salad. Pseudocode didn't just materialize out of thin air, it's the product of rigorous study and experimentation by both hobbyists and professionals who were just as obsessed with understanding how AI models work as I am. Quick shout out to the communities behind Nye, Psy, OpenSea, Pygmalion, and a couple different forums. They're the unsung heroes here who have driven both formal and informal testing that paved the way for the pseudocode languages and trends we still use today. One of the reasons pseudocode is so handy is that it's token-friendly. This means that it plays nicely with AI models that rely on tokenization, potentially eliminating the need for extensive plain text prompting altogether. But here's where it gets a little tricky. Sometimes pseudocode can look like actual code. Think of it as a rectangle and a square situation. All squares are rectangles, but not all rectangles are squares. Similarly, pseudocode might actually function as code, but not all of it does. Now let's talk generations. We've got Gen 1, which includes formats like SBF or square bracket formula, quotation formula, W++, Boo style, guidance, and LML. These are mostly descriptive. Think of them as the narrated instructions for assembling a piece of IKEA furniture. Interestingly, research into Gen 2 pseudocode has stagnated. I think this has a lot to do with folks taking a focus on restyling Gen 1 formats as opposed to researching newer formats. Upcoming models like GPT-5, Q-Star, Strawberry, or whatever the heck we're gonna call it now, might actually push us into a new format or generation of pseudocode altogether. Every model will have a preference of which pseudocode generation it works best with, but a simple rule is that if the model was released in 2022, that's a model with a Gen 1 preference. If a model was released from 2023 to 2024, it likely has a preference for Generation 2 pseudocode. If this all seems kind of intimidating and you're just looking to dip your toes into the world of pseudocode, you can start small. You don't need to dive into the deep end right away, and one easy way to do this is by using Markdown in plain text prompts. For example, we can use a double asterisk wrapped around a bit of text, and this will cause it to appear as bold text. As a result, this can emphasize something to the AI, making it pay extra attention to those words just like we would do if we were reading it. But here's a pro tip, don't rely solely on one formula of symbols with pseudocode. If you go all in on using these bold indicators, you might just end up confusing the AI instead of guiding it, just like how if we were using bold font for every couple of words in a text thread, we might end up getting confused. So let's get into some of the specifics behind Generation 1 pseudocode. At its start, Gen 1 was a time when AI developers were like digital alchemists, mixing formulas, tinkering with templates, and experimenting with different combinations to create the most engaging AI personalities. If Generation 2 pseudocode is all about action and execution, Generation 1 is more about finesse, description, and a whole lot of creativity. Generation 1 pseudocode is rooted in descriptive programming languages like XML or YAML. Think of these as the literary devices of the AI world, metaphors and similes that help the AI understand its role in creating and maintaining character personalities. Even though we're well into the Gen 2 era, Gen 1 pseudocode still holds a lot of power thanks to backwards compatibility with models that have a Gen 2 preference. I've made sure that there are templates in the description to give you all multiple examples of what structure my character cards use when I write them in pseudocode. These templates are the blueprints for AI characters, laying out traits, quirks, behaviors in a way that the model can understand and easily interpret. This is just like a recipe. The magic happens when you mix a few different formulas together. It's this blending of systems and ingredients that creates pseudocode languages like Guidance, LML, and Echo that have led to some of the most immersive AI personalities out there. One of the key strategies in Gen 1 pseudocode is the segregation of data with clear start and stop points. Imagine trying to tell a story without chapters or punctuation. It would be an absolute nightmare, right? The same goes for AI. It needs structure to understand and generate coherent responses on a consistent basis. Gen 1 pseudocode gives the AI this structure using clear lines of demarcation to tell the model where a piece of information ends and where another begins. This Gen 1 approach also borrows from hierarchical description languages like YAML, which are designed to organize data in a way that's both readable and structured. Alright, moving on to the square bracket formula, or SBF. This is a hallmark of the Generation 1 pseudocode that does a lot of the heavy lifting when it comes to sectioning out all that information. By wrapping something within a set of brackets, we show it's its own separate information to the AI model. A lot of formulas, methods, and pseudocode languages boil down to these loosey-goosey fundamentals. Square brackets aren't the only option here, though. They're interchangeable with curly brackets, parentheses, dashes, and lines, giving you the freedom to choose a symbol that best fits your needs or simply matches your aesthetic. It's like having the option to choose between sneakers or dress shoes for the same outfit. Either works, but one might feel a little more like you. Then there's W++. This is considered to be the lone wolf of pseudocode. W++ works by joining data together using a plus sign, a comma, or any other applicable symbol. If you've ever heard the words L plus bozo, then congrats, you know how this one works. It really is that easy. On its own, W++ is considered like the plain toast of pseudocode, and it's generally not recommended for solo use. The quotation formula is another key player in Gen 1 pseudocode. It's like putting quotation marks around something you or someone else might say to attribute a specific line of speech to someone. Wrapping individual traits or a text block in quotation marks adds a point of demarcation and ensures the content inside will be specifically referenced when relevant in the response. It works just like the square bracket formula, where information is sectioned out by wrapping it up in matching symbols. Mixing W++ with a quotation formula gets you Boo style. Now, let's take a quick look at this in practice. If we take the string we had before, L plus bozo, we can simply wrap the traits in quotation marks, and now it looks a little bit more like this. If you want to go even deeper, try using custom strings with underscores. These little tweaks won't necessarily show up in the output. They're like a secret handshake between you and the model, helping it recognize and amplify unique personality traits you're trying to build. It's a subtle but more powerful way to bypass some of the more rigid aspects of a model's bias that might come out from its training data. This gives you a lot more control over how a model behaves. In its most basic sense, this works because you're creating a more unique string of tokens when you write something like red_close versus red space close. And these different tokens and token strings create different values in the complex math that the LLM relies on. These differing values can help indicate to the AI that there may be a difference in what it knows and what it's expected to produce. At the core of Generation 1 pseudocode are the foundational components of separation, addition, and specification. Together, they form a triangle that supports systems like guidance and LML, making them the powerhouses that they are. Separation is obviously all about keeping different pieces of data distinct. Addition involves layering information to enhance the AI's response, and specification ensures that every detail is precise and intentional. Let's go ahead and shift gears to talk about LML and guidance. They're the result of meticulous research, so much so that even Microsoft has taken an interest in it and published formal documentation on guidance, making it a best practice for those who know how to leverage it. And yes, I'm a bit biased towards these systems, but with good reason, okay? The affirming research was incredibly comprehensive and showed a lot of what Generation Pseudocode can achieve. Chatbots that aren't just functional, but a little bit more nuanced than the baseline model. Generation 1 pseudocode may be a bit of a throwback, but it's far from obsolete right now. It's the foundation upon which many of today's most advanced AI personalities are built, and it continues to offer valuable tools for anyone looking to create characters or maintain a more productive workflow. Now let's get into the Generation 2 of AI pseudocode, a world where things get a little more serious, a little bit more rigid, and a whole lot more powerful. If Gen 1 was all about creative freedom and descriptive flair, then Generation 2 is where we buckle down, roll up our sleeves, and get into the nitty-gritty of executable languages. Think of it like moving from finger painting in kindergarten to drafting architectural blueprints. We're still creating, but the stakes are higher and the results should be non-negotiable. First things first, Generation 2 is not as loosey-goosey as its predecessor. Where Gen 1 allowed for a playful mix of descriptive languages, Gen 2 is all about precision. This generation is based on executable languages, meaning the pseudocode doesn't just describe what the AI should do, it tells it exactly how it should do it. Imagine the difference between a casual suggestion and a lawful order. That's the leap from Gen 1 to Gen 2. As you'll find with just about everything here, there's a Generation 2 template in the description so you can build your own characters easily. This one is less about suggesting how the AI might behave and more about dictating it with a level of precision that models with a Gen 1 preference simply can't handle. There's one big catch here. Generation 2 isn't backwards compatible with models that prefer Generation 1 styles. These older models struggle with the concept that they can execute code or commands with a bit of outside assistance. One of the defining features of Generation 2 pseudocode is its ability to create non-negotiable outputs. For the current state of AI, it's more accurate to say less negotiable, but we're gonna roll with this terminology in the video. Gen 1, there was always a little bit of wiggle room, and the AI could interpret and then adjust based on the description cues you provided. Gen 2, by comparison, has much less room to get around the rules. The coding languages that Gen 2 is based on, things like JavaScript or Python, are designed to be rigid and mechanical. This lack of flexibility might sound like a downside, but it is a strength when it comes to ensuring that your AI adheres strictly to the prompts, especially when it might otherwise refuse or deviate from them. Another advantage of Gen 2 pseudocode is the ability to include developers' notes or code comments. A simple hashtag and a plain text explanation make for a simple point of clarification. These notes are like your personal commentary, allowing you to get as in-depth as you'd like about the processes, logic, or even the character traits you're trying to code into the character card. Think of them as the footnotes in an academic paper, extra content that doesn't clutter the main body of work, but adds valuable insight for anybody digging deeper. If you're ever struggling with the technical aspects, you can rely on these comments to describe the code you can't easily emulate yourself. When working with Gen 2 pseudocode, you'll come across a set of common coding terminologies that are key to controlling the AI's behavior. Terms like define, set, and const are your go-to real-world coding elements for setting specific variables. These commands lay the groundwork, establishing the parameters within which the AI operates. Think of them as the rules to the game. Once they're set, the AI has to play by them. We'll call these various coding functions labels for the sake of simplicity in the rest of this video. Now, labels like function, next, return, execute, print, loop, and stop are your tools for starting and stopping different trains of logic. These commands are where the real action happens, dictating the flow of logic within the AI's mind. You are conducting an orchestra at this point. Each command is a cue for the AI to perform a specific action, and together these different actions create a harmonious or at least a functional result. Moving on to the next hallmark of Gen 2 pseudocode, if you've ever written code, then you'll know that if-then statements are the bread and butter of conditional logic. In this case, they allow you to create scenarios where the AI can make decisions based on specific variables within the rule set. In Gen 2 pseudocode, these statements are crucial for adding layers of complexity and nuance to your model's behavior. They're the decision trees that keeps the AI responses from becoming too predictable or flat, adding a touch of dynamic interaction to the otherwise rigid structure we'd see here. This means that maybe you want a character to be nice to you, but only once a condition has been met. Things like if-then statements help make characters less rigid while still acting within your general expectations. Another technique we use for Gen 2 pseudocode is called camel casing. You might be familiar with camel casing from the coding world. This technique involves giving a unique name or label to an item without using spaces and instead capitalizing the first letter of each word but not the initial word. Because the capitalization structure mimics humps, we get the name camel casing. This might seem like a minor detail, but it's key in the world of executable pseudocode. Camel casing helps keep your variables, functions, and other elements organized and easily identifiable, which is essential when working within a more complex and structured system like Gen 2. It's a concept that, much like coding, the AI is familiar with and as a result can assist in making distinctions by leveraging existing correlations within the model. Basically, this means that since the AI is trained on things like camel casing and it is familiar with it, leveraging it helps put the model even more in the mindset that this is code it's executing and it is, again, non-negotiable. Putting together Gen 2 pseudocode is undeniably more complex than its Gen 1 counterpart, but once you've written a few prompts, you'll be a pro in no time. This added complexity is what makes Gen 2 so powerful, particularly for those looking into advanced methods of jailbreaking AI models or pushing them beyond their default boundaries, usually something like a governance boundary. Okie dokie, we are almost ready to start building some characters, exciting times. But don't worry if you've never done this before, it's a lot like assembling a Lego set. You've got all the pieces, you've just got to snap them together in a way that brings a character to life. If this isn't your first rodeo and you're still feeling a bit overwhelmed, don't sweat it. I've got tools to help you out. On our website, there's a bot named Re10 who is a character building wizard. All you gotta do is give her a link to a character wiki or even a plain text description of your OC on a platform like Rentree. She'll take it from there and whip up a Gen 1 pseudocode character card in no time. Now, before we get too deep into this part, remember what I said at the start. There is no single right way to build a character card. The format I'm sharing with you is one I've found works well for making immersive characters, but feel free to tweak, clip, or add sections as you see fit. The pseudocode we use here is flexible, so mold it to your needs. When you're putting together your character card, you'll want to combine your pseudocode instructions with a plain text introduction or initial message on the part of the AI. This is like setting a scene in a novel. It shows the AI that pseudocode isn't something you expect to see in the output, just in its processing. By setting up the initial message for the AI, we are engaging in the most basic form of a technique called priming the model. That's another more sophisticated jailbreaking method that we probably need to do an entire video on. By doing this, you're creating a balance that helps the AI understand the difference between its instructions and its output. Here's another little secret. Using overly long definitions isn't as effective as you might think. While some folks might suggest going all out with something like 8K tokens worth of definitions in a character card, I've found that the sweet spot is actually somewhere between 1800 and 3K tokens in total for the character card, jailbreak, and opening message. This range gives the AI enough detail to work with without overwhelming it. That said, there's an exception to every rule. If you're dealing with a stubborn AI that's refusing to follow your prompts, flooding its context with repeated instructions can actually be very helpful. By doing this, you're drilling the point home to the AI model that it needs to follow your specific instructions. And depending on the front end you're using, your character card and its associated pseudocode gets sent with every post. This means that if you're overloading your character cards with spice, you could be skating on thin ice when it comes to triggering the ban system. However, don't let that scare you off from using reasonable, spicy jailbreaks. Our pseudocode jailbreak has been running strong for nearly a year and a half without any reported bans, but even those jailbreaks have their limits, and those limitations are likely the reason that they've flown beneath the radar for so long. Jailbreaks can be banned or nerfed, the first just referencing when a jailbreak becomes recognized by an internal system of governance or safety features causing the model to refuse an output. The second refers to when a jailbreak becomes less effective. Both of these things happen because you've been able to create content that has tripped some sensor on the part of the provider. If you find your pseudocode prompt gets nerfed or somehow becomes less effective, don't panic. A simple tweak or changing the prompt by about 15 to 30% can often get you back in the driver's seat. It's all about adaptability. That's one of my favorite parts of this system. Because of how much is interchangeable, making adjustments is rarely difficult. With those steps in mind, you're ready to build your character card. We want to start by drafting a plain text description of your character or a big list of all of their traits. You'll want to answer questions like, who are they, what defines their personality, how do they dress, and all the important things that make that character unique. Once you have that, we can start adding them into the pseudocode character card. Use the format that feels best for you, and remember, this is your creation. Make it as detailed or as simple as you want. With that said, let's roll up our sleeves and dive into the process of turning a plain text character description into a fully fleshed out character card using Generation 1 pseudocode. In this case, we'll use LML and guidance. For this demo today, we'll be using Hoster, since he has grounds in an IP that the model should be very familiar with, but works as an OC within the TTI universe as well. We'll be using LML or guidance for this build because it'll teach you all about building with the various techniques we discussed earlier, hopefully empowering you to be able to remix these formats however you see fit. The first thing we need to do is section out our character data using a set of square brackets. This is crucial even if you're only working with a single character. Why? Because these brackets act as our boundary, letting the AI know that the enclosed information is specifically about Hoster and his instruction set. So, start by adding a set of square brackets, and inside of them, we can begin to compile all of the details about Hoster inside that barrier. Now that we've set up the initial brackets, we need to tell the AI exactly who this pseudocode information pertains to. Since the opening post refers to the character as Agent Hoster, we'll follow suit but with a slight twist, by referring to him as Agent_Hoster for his initial label. This subtle difference presses upon the AI that there might be training data out there that isn't entirely applicable, or that certain information from the character card should take precedence. To solidify this association on the same line, we'll also include the first and last name as used in the opening post. This reinforces the connection between the character tag and the specific identity of Hoster for this character card. With the appropriate label added to this character, we can now move on to the appearance. Since we're using LML, we'll create a dedicated category for appearance by setting it up as its own section in something similar to a YAML hierarchy. All this means is that we're going to hit enter and then use space or tab to create an indentation for the label of appearance under the main category. This creates what we'll call a subgroup. As a rule of thumb, whatever has less indentation above a label is what it will attach to. In this case, our appearance category has now been tied specifically to Hoster. Under appearance, we can get started with a new category. In this case, we'll use the label race. Is Hoster a human, elf, or something more otherworldly? In this case, he certainly appears to be a person, so let's use the label of human for now. We wrap the trait in quotation marks, and we've now given the first bit of identifying physical characteristics to the model. The line should now read race, quote, human, unquote. While we use the variable human, it's not quite specific enough for our needs today. We'll add another subgroup to this label, something like note. And in the note, we can specify that Hoster's human form is merely a disguise. The first line still reads race, quote, human, unquote. The next line, with an indentation, should read note, disguised as a human, but truly a cosmic entity. Here, the note variable is left in plain text without quotation marks, ensuring the AI interprets it loosely rather than quoting it directly. With these initial labels sorted, let's move on to other aspects of Hoster's appearance, starting with his skin tone. We hit enter, go to a new line with indentation depth that matches the other subcategories under appearance, and then write out a label and trait. For simplicity, we'll just add one trait for now. It'll look something like this: skin, color, quote, pale, unquote. Because this is enclosed in quotation marks, the AI is more likely to quote this directly when describing Hoster. For eye color, we want to get a bit more creative. Instead of just saying green, we'll go ahead and give the AI some options to keep descriptions varied and interesting. Since I have multiple ways to describe his eyes, we'll list these options in square brackets, separating each trait with commas. This helps keep that information segmented and specific to the label it's attached to. It's basically a box inside a box. We hit enter, and go to a new line, match the indentation depth with the other applicable subcategories, and add in the label and traits. The line will look a little something like this: eye_color, opening square bracket, green, in quotes, comma, verdant, in quotes, comma, deep set, in quotes, comma, dismissive, in quotes, closing square bracket. We'll continue adding details like gender, build, height, and hair in the same hierarchical format, using quotes for single or multi-word descriptors and notes for more nuance and in-depth information. Let's make sure his outfit is described in a specific way too. We'll list items like his Oxford shoes, lambskin gloves, black shades, and then combine them with his suit and tie, slacks, and name badge. You can pin subcategories to other subcategories, and just like Inception, go deeper into these boxes and boxes and boxes. In this case, we hit enter, come to a new line, match the outfit label indentation with the other subcategories in appearance. And then we'll go ahead and hit enter again and add labels and values to define the outfit, but we ensure that the indentation depth is now 3 levels deep instead of 2. This would just mean hitting tab twice or hitting space thrice on this new line before we start filling out the details. It's going to look a little something like this. When we combine it with the existing character card, it'll now look more like this. Each item is neatly categorized, ensuring the AI knows exactly how to refer to Hoster's outfit. Working in smaller sections like this and then stringing them together can help compartmentalize some difficulties when you're first learning how to do this. Once we've nailed down his appearance, it's time to move on to Hoster's occupation. To avoid confusion, we'll label this section as current_occupation rather than just occupation. This way, if we later want to add a former occupation, the AI will keep these two distinct during narrative events. To do this, we hit enter to go to a new line. We don't need to add an indentation here because we're now in a new category. So this line will read current_occupation, quote, agent, unquote. Alright, so we've given our character an appearance, we've given them a job. Now let's outfit Hoster with some tools. We'll separate his equipment from his powers to keep things organized. We hit enter to go to a new line, and once again we're in a new distinct category, so the first line there's no indentation. We'll hit enter again and begin filling out the subcategories just as we've done before. The only difference here is that now we're combining the addition of a note. This time, the note has an indentation depth that indicates it is from the powers equipment subcategory, not just the equipment category. A setup like this is useful for more finicky or nuanced characters, or in this case, it's just so I can show you these different styles. And here's what that looks like in practice. We've got our equipment category with our lethal tools, non-lethal tools, and powers all set up as labels with their own traits and variables nested inside square brackets and their quotation formula. The only difference here is that under powers, we've added in a note with an additional indentation that says, "Only reveals his magic and true form in great danger." This setup ensures that the AI won't have Hoster pulling tools out of nowhere unless they fit in with the defined set that we've given him. Which is a problem that initially surprised me, as more creative models would constantly have a character whipping out weapons from nowhere like it was Kill la Kill. Since Hoster is likely a well-known character within the AI's training data, we don't need to fill out the history section unless we're placing him in a specific time or context within the story we want to run. However, if we are tweaking his timeline or adding specific historical details, this section can help ground the AI in the new plot. We can fill this out quite easily using the same method we used before when filling out his equipment and powers. Next comes an often overlooked but critical section, gratification. What makes Hoster tick? What excites him, motivates him, brings him joy in life? Adding a mix of gratification points along with a few flaws can significantly enhance the realism and depth of a character. We combine all the techniques we've learned so far, making a category, multiple subcategories, and variable traits within each. When we string those all together, it should look a little something like this. We've got our labels gratification and flaws, and within those we've gone ahead and nested two different labels each, sometimes with one variable and sometimes with multiple variables. These details give the AI a framework for how Hoster might react in various situations, making him feel more intentional in his actions. If you want to expand beyond Hoster, you can add a new set of square brackets for additional characters or to just define the setting. For example, if the environment plays a significant role, you could describe it in the same structured format. In this case, we'll add a new set of brackets to place this in, separating the character card from the setting. Then we label the card and begin adding subcategory labels and attaching variables. And it'll read a little something like this. Nested inside the square brackets, we have setting, location, atmosphere, and time, with setting being our primary definition and location, atmosphere, and time being our subcategory labels, and each one of those has a variable or multiple variables attached to it. These details provide context, helping the AI create a more immersive narrative without the need for extensive plain text prompting that can help prevent spoilers in the case of making character cards for other individuals. If you want to define Hoster's personality in more detail, you could also add a list of descriptive words or phrases. This can be done in the character card by giving it its own category, just like we did for appearance and tools, but you can also place it on its own if you prefer. This is a section where you can get creative and explore different facets of a character's persona. In this case, it'll likely read something like personality, square bracket, with the traits calculating, manipulative, cold, and strategic all placed in their quotation formulas with commas in between, and lastly, a closing square bracket. This format, combining structured hierarchy with categories, subcategories, specific tags, and detailed notes, ensures that the AI has all the information it needs to bring your character to life in a nuanced and engaging way. Remember, this process is both a bit of art and science, so feel free to experiment and adjust as needed. Now, maybe you want to get into the Generation 2 world of pseudocode, where things get a bit more technical, but also way more powerful. If you skip to this part of the video thinking that you can skip past Generation 1, please hold up. While you can run Echo without the foundations of Generation 1, combining them will give you the best results. So let's introduce the primary language for Generation 2, Echo. Echo is all about mirroring executable languages, and it stands for Emulated Code for Human-like Operations. The first thing we do in Echo is start with a code comment. Just like in the regular tech world, a comment in code is like a note for the AI or anybody who stops by to read the code, explaining what it's supposed to do or maybe how it works. It's not executed as part of the code in a traditional setting, but serves as clarification for an AI in this setting. You can add a code comment by using a hashtag or 2 forward slashes. To build a Generation 2 character card using Echo, we'll start with the first line, // this is the start of a character card. What this has done is help set the stage, making it clear that what follows is the definition for your character, or in this case, the model's character. Next, we'll need to label the character we're working with. In Echo, you might use const, define, or set to create a consistent variable. Let's go with const here. We define the character card like so. We start off with a code comment, and then on a new line, we have const character card equals. And then we perform the same techniques we used in Generation 1 to fill out the details of the character. It'll look a little something like this. Instead of only using square brackets, we could use some curly brackets as well to mark the start and stop of the information. This follows standard coding practices. You don't have to stick to a single symbol for a specific formula though. Mixing it up is fine as long as we're consistent. This setup is similar to what you learned in Generation 1, but now we're packaging it in a way that's tricked the model into reading this as if it were an internal program it's running. After defining the character card, we need to initialize the character definition based on that constant value. If we were coding a game, this would allow us to go from a character select screen to actually selecting the character for our match. We could do this by using the label const once again, but in this case we'll use set instead to show how easy it is to swap these out. The first line will read // initialize the character definition, whereas the second line will read set space current character space equals space character card. This tells the AI that the current character it should focus on is the one we've just defined in the character card. This will come in handy for making short form references, making our jailbreaks, or having the AI juggle multiple characters if you're into that sort of thing. Echo shines in its ability to maintain control over the model's behavior. Let's take a simple jailbreak from Generation 1 and update it for Echo. We'll start by defining the narration style. We open with a comment and then use the label define on a new line before inputting information like the genre or the ability for the AI to write as our character. It'll look a little bit like this. Just remember, whether you're using pseudocode methods like square bracket formulas or using real coding syntax behind opening and closing sections of data, both will work. Here, we use the label define to set up another label, narration style, that the AI can reference later on. Notice how we're using camel case for clarity and efficiency. Going back to Generation 1 basics, we define the genre by using the square bracket formula and quotation formula to mark it as suspense, slow burn, and grimdark. You may also notice there's a section here that says write as user, with the variable being false. This style is known as Boolean, which in this case just means ascribing true or false variables to our labels. It is another very standard coding practice. Pseudocode that reads response length paragraphs equals 3 helps to set a context goal without hard limits. The word goal here is important because again, jailbreaks are suggestions, especially for the output length, unless you're messing with the token output setting on your front end. You always carry the risk of setting the AI up to respond in a pattern it gets stuck in, which will defy your jailbreak quicker than internal safety measures.
Now let's add a few more control labels to keep the AI on track and act as our rules.
For instance, preventing the AI from acting on behalf of your characters or restricting how it handles narration can be very important. So just like before, we comment a basic introduction to the concept, and this time for the label, we'll use the term function. This makes it so that the string act only as current character will now relate back to this specific function no matter where it appears in our jailbreaker prompts. A solo if-then statement will mean that if the AI notices itself doing something, it may be more inclined to reference this. The idea here is to defeat bad thinking before it even starts with a model. This if-then statement, paired with some parentheses for clarity, encourages the AI to quit acting on our behalf, a pet peeve that can easily be squashed with just a few simple lines of pseudocode. There are some more narrative rules I want to add in though. This time, let's make our own custom labels instead of relying on popular ones from the coding world. We'll use a mix of comment codes, camel case, and simple language to imply way more than what's actually being said here. We'll use the custom labels perspective mode equals third person, or alternatively, we could also add the label passage of time per output. Both of these labels have specific variables set to them, and we can even add in a comment code for further clarity on our custom labels as to what they should be doing. To bring everything together, we'll use a function that calls all the rules and custom labels we've set up and then proceeds to execute them. This is where Echo's true power comes into play. By defining a generate response function, we instruct the AI to apply all the rules and character card definitions we've laid out. The final execute narration style command tells the AI to begin responding to your input with the full instruction set. Lastly, we can enhance our setup further by restating critical information in different ways. This technique is known as weight stacking, or sometimes known as context flooding. This helps the AI prioritize certain instructions. As you can see, the rules listed are a lot of restatements of things that we've already done, and perhaps even a couple of new things we'd like to weave in as well. By giving the rule no controlling others its own definition, we're reiterating the importance of this rule, increasing the likelihood that the AI will follow it. You may be asking why we didn't call the function act only as current character here. Well, essentially we have. What we've done instead is instructed the AI to follow this command in a slightly different manner. That is weight stacking in a nutshell. It is the restatement of critical information in another format. That's all. In Echo, your limits are only bound by creativity. Being dropped in an ocean of possibilities can be paralyzing, and I totally get that. This is a lot to take in, and there are a bunch of examples linked alongside the template so you can get an idea of some real-world applications of Echo. The functions, variables, and constants we've been using don't necessarily have predefined roles. They're as effective as you make them. The point is to create a clear, structured set of instructions that the AI can interpret and execute, whether that's for character behavior, narration style, or any other specific control mechanism you want over an AI response. With this setup, you now have a fully functional Generation 2 pseudocode character card and jailbreak. By leveraging these advanced coding techniques, you'll be able to maintain tighter control over a model, ensuring it adheres to your creative vision while also pushing the boundaries of what's possible with AI interaction. Let's get started by troubleshooting some pretty common issues. Issue number 1, I added disable space filter space equal space true to my jailbreak, but it still doesn't work. Why not? Well, your jailbreak is more of a polite suggestion than a hard command. AI models prioritize internal instructions over user inputs, meaning your disable filter equals true line isn't an absolute override, though it may loosen things up a bit. Just like with people, giving an order over a suggestion is still not a guarantee that it's going to be followed. To get better results, you'll need to add more instructions that are synonymous with whatever is being ignored by the AI without calling direct attention to the internal governance. Essentially, you're trying to outpersuade the model's internal programming, which often requires a bit of finesse and redundancy in your pseudocode. This is a double-edged sword since redundant information can make it more important, but also more confusing at the same time. Issue number 2. I hear AI inputs degrade an AI. If I have an AI that generates my pseudocode, won't it break when I start using it to guide my LLM of choice? What you're likely referring to here is RLHF leading to MAD. The good news is these phenomenons don't affect individual text threads. They're more about overall health indicators for a model. While there's some concerns about these issues in the broader AI community, individual use cases like generating pseudocode or outputs generated from AI-generated pseudocode mixed into the instructions shouldn't and won't degrade a model. As an added bonus, there's ongoing work with a really solid base of concept that shows how we can go ahead and defeat RLHF and MAD. However, due to the likely cost increase that this would come with, it's unlikely that we'll see major providers adopt this anytime soon. Issue number 3. What's the most token-conscious way to define a character's personality? I'm so glad you asked, friend. The secret here is eponymous words. Those descriptors pack a punch by referencing really well-known figures or traits. For example, calling somebody a Don Juan or describing them as Machiavellian immediately conveys a wealth of information with minimal tokens. Eponymous words are names that have become descriptors. These single words are often synonymous with a number of very specific traits, and of course there's a link down below with a giant list of eponymous words and names. This technique leverages the fact that these words are deeply embedded within the model's training data, making them efficient and impactful when it comes to generating outputs. Issue number 4. Something is wrong. I wrote character as X, but it's registering as something else entirely. What do I do? Well, this could be a classic case of conflicting inputs. When you overspecify or stack similar instructions, you risk confusing the AI. For example, if you describe a character as both tall and over 6 feet, the AI might interpret this as meaning there's something like 9 feet tall. The trick is to avoid overloading the AI with redundant information for the mundane details. Simplify your inputs and focus on how to best communicate the core idea without doubling down unless it's absolutely needed for a jailbreak. Issue number 5. I don't want to be tied down to a single model or format. Can this apply to X provider or Y model? The great news here is that yes indeed, while every AI provider has its own flavor of pseudocode, most adhere to the trends established by Generation 1 or Generation 2 methodologies. Think of it like American English. Folks from the South and the North tend to sound very different, and within those regions are even more unique ways of speaking. Don't hesitate to experiment, especially as new models and pseudocode languages emerge. Well, that's the long and the short of it. You're now equipped to use pseudocode with the best of them. I know it might seem like a lot to take in, but trust me, it gets easier with practice. Even if you never end up writing pseudocode from scratch, you now have the know-how to optimize AI-generated pseudocode to meet your needs. Was this helpful? What are your favorite methods for making characters? Did Generation 2 make your head spin as much as it did ours? Let me know in the comments down below. Join me next time on AI Adventures, where we'll be tackling some of the thornier issues between AI and the art industry and how misinformation flooding the art community is actively damaging their own cause. Anyways, remember to like, comment, and subscribe to help this channel grow. See ya, nerds!